So what's up guys, and welcome to this video where we will be going over June 2023 mechanics. Let's go. So first question, we've got a car which is initially at rest on a straight horizontal road. The car then accelerates along the road with constant acceleration, 3.2 meters per second per second. We need to find the speed of the car after 5 seconds. So this is just a nice SUVAT equation. So let's just write all of our SUVAT down. So we have S. Okay, well we don't know what S is, so we can keep that as S. We know what U is because it's initially at rest, so U is 0. We don't, do we not V is? Yes, we're trying to find out what V is. So actually, that's what we want to work out. So I'll leave it as V for now. We know A is 3.2. And we want after 5 seconds, so T is 5. So therefore, we want to work out V. We have U, A, and T. So we can use this SUVAT equation. V is equal to U plus AT. Therefore, V is equal to a 0 plus a 3.2 times a 5. And if you do 3.2 times 5, that is a 16 meters per second. Okay, that's 1A done. And for 1B, we find the distance traveled by the car in the first 5 seconds. So now this is where we want to work out what S is. Okay. Now, we can use what our V value is, but I would say even though you can be fairly certain you're correct, it's probably best just to use the other values which were given already instead of using your newly found V. So we will use the formula S is equal to UT plus a half AT squared, and therefore that would be S is equal to a 0 times T, so that cancels out. So we're left with a half times a 3.2 times a 5 squared, okay? And then if you work that out on your calculator, you will get 40 meters. So for question 2, we have this particle P as mass 5 kilograms, and the particle is being pulled along by a horizontal force of 28 newtons. We're on a rough horizontal plane, so we have the frictional force that is denoted by F. And we need to find the magnitude of the normal reaction to the plane at P. So what I'm going to do is I'm going to draw a little diagram as well for this. So if I draw a little diagram down here, okay, what do we know? Well, we have this particle P, which is, let's say, here, and we know that there's a horizontal force of 28 newtons, and it has a frictional force here, okay, that's F newtons. We also know that its weight, it says, is 5 kilograms, so we're going to have a downwards force, because its mass is 5 kilograms, over a downwards force of 5 G newtons. And then because it's rough horizontal plane as well, not only that, we're going to have a normal reaction perpendicular to this horizontal plane. Let's call this R newtons, okay? So for the first question, find the magnitude of the normal reaction on the plane at P. Well, that's very simple to do. If we just resolve forces in the vertical direction, we can clearly see that R has to equal 5G. Okay, so that's part A done. Part B, we are told that the particle is accelerating along the plane at 1.4 meters per second per second. Okay, so it's accelerating along the plane. So what does that mean? Well, we know that it's being pulled along by the horizontal force. We know it's going to the right, which we can also gather that because friction always works in the opposing direction of motion. So we know it's going to the right, and we know that it's going to have, if I do it here, it's going to be, has an acceleration of a 1.4 meters per second per second. So now we need to find the value of F. Well, we can just use F is equal to ma to find that out. So if we do that, if we resolve forces again, but this time we use the F is equal to ma because we are moving, then that will be a 28, okay, minus the F, and that will be equal to ma. So m, the mass is 5, and then a is the acceleration, that is 1.4, okay? Therefore, that is a 28 minus an F, 1.4 times 5 is a 7. And therefore, if we rearrange to work out what F is, well, then F would be a 21 newtons. And for part C, we're told that the coefficient of friction between P and the plane is mu. Find the value of mu given your answer to two significant figures. Okay, so we know that, so what is the formula? Well, the formula would be the friction is equal to mu r, okay? So in order to work out what mu is, well, we know what the friction is. We know the friction is 21, and then we have mu here. We know the reaction is 5g. So then it would just simply be, mu would just simply be 21 divided by 5g. So g being 9.8. And if you put that into your calculator to two decimal places, okay, we can actually simplify it down first. So it'll be a fraction, 3/7, and then to two decimal places, that will give you a 0.43. So for question 3, we have at time t seconds where t is greater than or equal to 0, we have this particle p has velocity of v meters per second, and then we have this equation for v, okay? So it's like a variable acceleration question with vectors as well. Okay, so what do we need to do? Well, we find the speed of p at time t is equal to 0. So for this question, all we need to do is put 0 into t, okay, and then that will give us the velocity, right? Because it will give us direction, right? Give us velocity. But then after that, we can just use Pythagoras theorem, and that will give us the speed. So first things first, we need to put 0 into the equation. So this is part A. So if we put 0 into t, what do we get? Well, we get v is equal to 0 squared minus 3 times 0. So we'll just be left with a 7i, okay? And then for the j, that'll be a 2 times 0 squared, which is 0, minus a 3j. So we know that the velocity at time when t is 0 is just 7i minus 3j. To find the speed now, it's just Pythagoras theorem. So that'll just be a 7 squared plus a 3 squared, all square rooted, and that will give me root 58. And to be honest, that you'd think that would simplify down and be like a, I don't know, simplify down to a third. It doesn't. It would just stay as root 58. So you can leave it as root 58, and that would just be meters per second, okay? Now for part B, okay, we need to find the value of t when p is moving parallel to I plus j. So what does that mean? Well, if I write what v was, okay? If I write what v is, so we know that we have this t squared minus 3t plus 7i plus the 2t squared minus 3j. Okay, that's v. What it's saying is if it's moving parallel to I plus j, then it must be some type of scalar I plus j. It must equal some type of scalar I plus j. I've used lambda as my scalar, and that's effectively what it's saying. So if we want to find out the value of t when it's moving parallel, well, we can actually do that because we can actually just compare values. So for example, if we look at just the i's for a second, right? Well, if we just compare the i's, we'd get a t squared minus 3t plus 7. I'm just looking at the i's, and that'll be the left side, okay? And then on the right side, we get a lambda I. So then that would just be like a lambda. And then for the j's, we would get a 2t squared minus 3. That's the j components. That would equal a lambda j. So then that would also just be a lambda, okay? So now we're at this stage, well, now we can see that both these must equal lambda. So if we look at the value of t, well, this is just like simultaneous equations, and we can just put them together now. So it'll be t squared minus 3t plus 7 is equal to 2t squared minus 3. And now we can just work this out. So what would we get? We get a 0 on this side. We get a t squared. Bring that 3t, so we get a positive 3t, and then a minus 3, and then we get a minus 7, so we get a minus 10. Okay, so now we've got a t squared plus 3t minus 10 is equal to 0. Now if we factorize this, we get a t plus 5, t minus 2, that would equal 0, and therefore we're left with t is equal to minus 5 and t is equal to 2. But remember that in this case, t is positive. They also say that they say in the question here, t is always greater than or equal to 0. So therefore, our answer would simply, we can just, get rid of this one. Therefore, answer is simply just going to be t is equal to 2. Okay, for part C, we need to find the acceleration of p at time t seconds. So to find the acceleration of p, when we're dealing with these type of questions, okay, to find the acceleration, we just need to differentiate the velocity. In this case, we just need to differentiate the velocity. So, let me use a different thickness. So again, the velocity, what was the velocity? Well, the velocity was, if I just look at what I had, the velocity was a t squared minus 3t plus 7 I plus a 2t squared minus 3, and that's j. Okay, that was the velocity. So to find the acceleration, we just need to differentiate this. So therefore, the acceleration, which is the same as in this case dv over dt, that would give me a 2t minus 3. Okay, that would be your I components. And then we would get a plus 4t j. Okay, and that would be it for your acceleration. And for part D, we need to find the value of t when the direction of the acceleration of p is perpendicular to I. Okay, so we need to find the value of t when it's perpendicular to I. What does that mean? Well, if it's perpendicular to I, then that means that it will just be in this direction here. It will just be, well, no, it will be in this direction here, okay? Because if we consider I being the horizontal component and j being the vertical, if it's perpendicular to I, therefore we just will have a j component. It will be like either in this direction or it will be something in this direction, right? We'll just have a j component in this question. Therefore, what we can do is we know that if it's perpendicular to I, that must mean that I must be equal to 0, because there will be no I component because it's perpendicular to I. Therefore, we can just use what we've got for the acceleration, okay? And we can make the I bit 0, okay? Because we know that if I just, if we were to do this, we know that the I component would have to be 0. So what does that mean? That means that 2t minus 3 has to equal 0. And therefore, if we rearrange this, we get t as 3 over 2. So remember that if it's perpendicular to I, it means I is equal to 0. If it was perpendicular to j, it means that j would be equal to 0, okay? So just got to remember that. So question 4, we have some more vectors. We have particle P is moving on a smooth horizontal plane. Particle has constant acceleration of 2.4 I plus j meters per second per second. So what does that mean? Because it says constant acceleration, that means that we can use SUVAT in order to work out these questions. So just remember that if it's constant acceleration, we can use SUVAT. So at time t is equal 0, p passes through the point A. At 5 seconds, p passes through the point B. The velocity of p as it passes through A is minus 69 minus 3j meters per second, and we need to find the speed as it passes through B. Okay, so for this one, for part A, okay, we can just apply SUVAT to this. So what do we know? Well, do we have a value for S? If I look, no, we do not. We have no values for S, so we'll leave just S like S for now. For U, yes, we do, because it says that at time t is equal to 0, it passes through the point A, and we know this velocity as it passes through the point A is minus 69 minus 3j, so that will be our initial velocity. We were trying to work out the speed of v, so v would just stay v for now. That's what we want to work out. We do know A, they tell us it has constant acceleration of 2.4 I plus j. That's a 2.4 I plus j. And we want to work out the speed as it passes through P. We know that point B is at 5 seconds, so that would be T as 5. And now, similar to question 1, we can use the formula of V is equal to U plus AT to work it out. In the question, it asks for the speed, okay? So because it asks for the speed, it means that once we work out the velocity, okay, we just need to use Pythagoras theorem, and that will give us the speed. So let's work out the velocity first. So that will be a V is equal to a U, which is a minus 16I minus 3J. Okay, that is plus a 2.4I plus j, and that's all times by 5. So therefore, that would give me a minus 16I minus 3j. Okay, what is 2.4 times 5? 2.4 times 5, that is a 12. So we get a 12i, and then we just get a 5j. And now if we simplify this down, we get a minus 16 plus a 12. So we get a minus 4i, and then a minus 3 plus a 5. That will give me a positive 2j. So now we've worked out that the velocity is a minus 4i plus 2j, but we want the speed. So we need to use Pythagoras' theorem. So that'll just be a 4 squared plus 2 squared, all square rooted, and then that will give me a 16 plus a 4, so that gives me a root 20, which simplifies down to third form. That will be a 2 root 5 meters per second. So for part B, okay, we have that the position vector of A is 44i minus 10j, okay? And with that time t is equal to capital T seconds, where t is greater than 5, P passes through the point C. And then we're told this position vector of C is 4i plus cj. And then we need to find the value of T and then find the value of C. So this question is a bit more tricky, okay, because we've got two different position vectors. How do we work this one out? Well, this is how we could solve this one. So let's start with SUVAT, okay? So with S, okay, what we're told that the initial, so this would be the initial position vector. We're told the initial position vector is 44i minus 10j, okay? That's the initial position vector. And then we're told that after a certain amount of seconds, when it passes through point C, there we get a 4i plus cj. So what does that mean in terms of the position, okay, the position vector? Well, if the position vector A, if that's our initial position vector, and then we end with the position vector at point C, then what can we say? Well, effectively, that is the same as saying, that if, like, imagine if we just gave it random values, for example, maybe this would be easier. Imagine this was just 20 meters, and then this was like 5 meters, right? So imagine our initial distance was 5 meters, and then we ended up after a certain amount of seconds, we were now 20 meters in that same direction, right? We would know that, oh, well, then we just traveled 15 meters, right? The same principle here, okay? If we know that our initial position vector is 44i minus 10j, we end at 4i plus cj, then we could just rewrite this for our displacement. That would just be a 4i plus cj, and that would be minus that 44i minus 10j. And that's what we're going to do. So that would be our S value. Okay, our S value would just be a 4i plus cj. Okay, and that is a 44i minus a 10j. Okay, so that would be our S. Now let's try and work out some of our other values. Well, our U would stay the same as it was in the other questions. So that would be a minus 69 minus 3j. Our A would stay the same because it's constant acceleration. That is a 2.4i plus j. And our T, well, that is what we want to work out. So that will just be a capital T. Okay, so now using this, we can actually work out what T is. And we will use this equation here. S is equal to UT plus a half AT squared. So if we do that now, we get a 4i plus a cj minus a 44i minus a 10j. Okay, and then that is equal to a, I'm going to do this in one go. So we get a minus 16t, okay, that'll be an I, minus a 3tj, okay, and then we get a half times a 2.4, okay, so that'll be a 1.2, and then we also get the t squared, so t squared I, and then we get a j, it'll be a half times that j, so we get a half j, and then don't forget also that t squared, okay, so then we get a j there as well. And at this point, it may be very tempting to maybe like join your C, work out the left side and then bring it over. But really, we don't know what that C is. So really, like with most questions with vectors, what we want to do is if we can get one side being something, the other side being something else, then we can always equate later on, okay? So now what I'm going to do is we have this on the left side. I'm going to bring that 44i minus 10j to the other side, and I'm going to conjoin all my I terms together and all my j terms. So if I do that, it will look something like this. We'll still have the 4i plus cj on this side. If I bring this all over to the other side, okay, well, then what would we get? Well, that would be a minus 44i, so it become a positive 44. So, and then if I look at what I have, I'm going to combine all my like terms together. So let's do the i's first. We'd have a 1.2 t squared, okay, minus a 16t, and then that minus 44i, I'll bring that over so that becomes a positive 44. Okay, and then this is all of our I components, and I'll do the same thing with the j's. Okay, so with the j, what do we have? Well, we have this half. I write it as 0.5 for now. So 0.5 t squared minus a 3t. And with that 10j, well, that would be a positive 10j, and then we bring it to the other side, so it becomes a minus 10j. So that would be a minus 10, and then that would be all of our j components. And now, as you can see, well, now that we've grouped all of our i's and j's on one side like this, it becomes pretty nice now, because as you can see, we can kind of just equate coefficients again, okay? As you can see, we have all the i's here, and we know that all of our I components, well, they must equal that 4i, right? And all of our j components must equal that c. So now we've got it in this form, it becomes very easy now to solve. So now, by looking at this, if we just look at our I components first, we know that 4 must equal a 1.2 t squared minus 16t plus 44. And if we know that, well, now we can just bring that 4 to the side. So if I do that, we get a 1.2 t squared minus 16t, and then that'll be a plus 40. Well, that just equals 0. Now we have a quadratic equation, okay? And again, with this sort of question, it doesn't say anything about showing all your workings for every single step. So when you get something like this, especially the fact that it's only like, how much marks is this worth? It's only a 3 marker, okay? Don't waste your time working out the quadratic like by hand, right? Just put it into your calculator, let it do it for you, okay? So if we do that, then what do we get? We get t as 10, or I should say capital T as 10, and we get another t as 10 over 3. So both these are positives. Remember in the question, it does say that right here, t must be greater than 5. Okay, so we know 10 over 3, that's 3.33. So we know that, okay, it can't be that value. Since t has to be greater than 5, we know that t is equal to 10. Okay, so we can just disregard this value here. So we know that t is, t has to be equal to 10. So if we know that t is equal to 10, that's part B done. We know that t is 10. And then for part C, well, now that we worked out that t is 10, to work out C, well, now if we just compare the j components together now, that would be that C is equal to a 0.5 t squared minus a 3t minus a 10, okay? And now if we just look at these components, well, now if we know that t is 10, we can just substitute that in. So we get C is equal to 0.5 times 10 squared minus 3 times 10 minus 10. Okay, and if we work all this out, what do we get? Well, we would get a C is equal to 0.5 times 100 minus a 30 minus a 10. So that would be a 50 minus a 30 minus a 10. And that would also give me a C as equaling 10. So question 5, we have a small ball. It is projected with a speed of 28 meters per second from horizontal ground. After moving for t seconds, the ball passes through the point A. Point A is 40 meters horizontally, 20 meters vertically, yada yada yada. Okay, going alpha to the ground. Use the model. Show that t is equal to 10 over 7 cosine theta. Okay, so for part A, we need to show that t is equal to a 10 over 7 cosine theta. So if we look at this one, okay, we know that. How do we do that one? Well, luckily we know what all of our displacement values are. So again, this is projectile motion, so we will do SUVAT, but we have to treat our horizontal components separately from our vertical components. So if we start with the horizontal, okay, let's write horizontal here, then what's all of our values? Well, our S value, okay, we know that horizontally from O to A it's 40 meters. Our U, what do we know about U? Okay, we know that a U is going to be, because we're doing horizontal first, a U will be a 28 cosine theta. Not theta, alpha. Cosine alpha. And then for this case, our T, well, we'll just treat that as a capital T. And we know that because we're in horizontal motion, it's just going to be S is equal to UT, okay? Because constant acceleration is 0, so we just have S is equal to UT. If we work that out, we get a 40 is equal to a 28 cosine alpha times T, and then we just want T by itself, so therefore that'll be a T is equal to a 40 over a 28 cosine alpha, and then that just simplifies down. Both of those values go into a 4, so that would go to a 10, that would go to a 7, therefore we're left with 10 over 7 cosine alpha. So for part B now, we need to show that tan squared alpha minus 4 tan alpha plus 3 is equal to 0. So how can we show that? Well, from part A, we've got that t is equal to 10 over 7 cosine alpha, and we know that we want some more values for alpha, right? Well, how can we work that out? Well, I think the first thing you should try and do in this situation, which I think most of you would do anyway, is we've already worked out the horizontal. Let's try work out the vertical component now. And usually with these questions, you have to work out the vertical and then do some form of simultaneous equations in order to work out usually your values for t. Well, in this case, because we don't have any value for cosine alpha or sine alpha, we're just going to have to do the same thing pretty much, but in terms of alpha, okay? So first things first, let's start by working out the vertical components, okay? Let's work out the time for the vertical components, okay? And let's see what happens there. So for the vertical, we're going to treat vertical as the upwards direction. Therefore, what would our S be? Our S is 20, because from O to A, remember, all of this is from O to A, that would be a 20, okay? Now, our U value, okay? Our U value is just going to be 28, and we're doing vertical, it's going to be a sine alpha. V, we don't know what V is, so we can leave V out for now. V is just V. A, we do know what A is. Remember that we're going in the upwards direction, okay? So therefore it would be a minus 9.8. And then a T, what we can do for T is we actually don't know what T is because we worked that in the previous question, that T is a 10 over 7 cos alpha. So therefore we can say that here. We can say that T is equal to 10 over 7 cos alpha, okay? And now what we can do is, using the values we've got, we can use the formula S is equal to a UT plus a half AT squared now, and now we can try and show that it equals that quadratic equation. So if we try doing that, we get a 20 is equal to a 28 sine alpha t, and that would be a plus a half times 9.8 is a minus 4.9 times t squared, so times by a 10 over a 7 cos alpha squared. So that'll be a 20. I also forgot to include my t value here as well, so let me do it now. So that will be a 10 over 7 cos alpha will be there as well. If we work this out, so we get a 4.9, that'll be times by 100 over a 49 cos squared alpha. And then if we do 28, 28 divided by 7 is a 4. So what do we get? We get a 20 is equal to a 40 sine alpha over cosine alpha, which is a 40 tan alpha. So that's good. We've got a tan alpha. That's the 28 sine alpha times by the 10 over 7 cosine alpha. So we get a 40 tan alpha there. And on this other side, okay, what do we get? Well, if we do a minus 4.9 times 100, but then we also have a 49 on the bottom as well. So really, that would be like a 490 divided by a 49 cosine squared alpha. That would give me a minus 10 over a cosine squared alpha. And that would be a 20 is equal to a 40 tan alpha. That'll be a minus 10. I'm going to change it to a sec squared alpha. Okay? So now at this stage, now this is where it gets a bit difficult. Not too difficult, but you just got to use some of your pure maths knowledge now. Just remember your trig equations. Obviously, you would have had your pure exam a bit earlier, so hopefully it'll still be fresh in your mind. But just remember from the trig, some of the trig identities and stuff, that a 1 plus a tan squared alpha is equal to a sec squared alpha. Okay, just remember that. If you remember that, you will be fine. So therefore, what does that give us? It gives us a 20 is equal to a 40 tan alpha minus a 10. Okay, and that'll be a 1 plus a tan squared alpha. And then if we just simplify all this down, rearrange, we get a minus 10 tan squared alpha. And then let's bring everything to the left side. So we get a 10 tan squared alpha. Okay, we get a minus 40 tan alpha. Then we would get that minus 10 comes over to the 20. So that'll be a positive 30. That's equal to 0. And as you can see, we can just divide everything by 10. Okay, and by doing that, we get a tan squared alpha minus 4 tan alpha plus 3 is equal to 0, which is exactly the form they want. So for part C, we need to find the greatest possible height in meters of the ball above the ground as the ball moves from O to A. So for this question, effectively, if we had a SUVAT, let me do it on this page. If we're thinking in terms of SUVAT, okay, we would just make that V value 0. And that's what we kind of can do. So if we have the vertical, okay, in that direction, then again, what we can do is we can make our... Actually, let me bring my diagram over just so you can see it. And voila. Okay, now we've got the diagram. So now what do we need to do? Well, we want to find the greatest height that this thing reaches. Okay, the greatest height. So for this question, we know that S is actually what we want to work out here. So S will just stay as S. Okay, be careful, it's not at 20. We want to work out what S is. We want to find the greatest height. U is still that 28 sine alpha. Now we know that with V, if it's the greatest height, that must be when our velocity gets to 0. Because once it reaches 0, it will just come back down. So V is 0. And our A, that is a minus 9.8. And that is all we need now to work this out. But we have this alpha value. Usually some of these questions, they usually give you what sine alpha is or cosine alpha. We have not been given that. However, what do we know? We know from the previous question that a tan squared alpha minus a 4 tan alpha plus 3 is equal to 0. And that's when we're working out between O and A. So we can actually use this. If we can work out the alpha value for this equation, we can use that for our alpha value. So if we work this alpha value out, well, we can factorize this. So feel free to maybe substitute a value for tan alpha, and then you can always substitute back in your tan alpha later. If I just factorize the tan alpha, okay, we get a tan alpha. We have a minus 4 and a plus 3, so that will be a minus 3 and a minus 1. So we have tan alpha minus 3 and a tan alpha minus 1. That would equal 0. Therefore, what do we get? We get a tan alpha is equal to 3 and a tan alpha is equal to 1. Okay, so now at this stage where we have tan alpha is equal to 3 and a tan alpha is equal to 1. Now, there's two ways you can do this. I would say the best way is, if we want to keep our answers exact, okay, we can actually just work out what sine alpha is instead of working out what alpha is. Because, for example, if you work out what tan alpha is equal to 3, if you work that on your calculator, okay, you do inverse tan to the 3, you get 71.565051118, right? You get loads of decimals. But if we want to keep it exact as possible, okay, what we can do is effectively we can just kind of manipulate the numbers and kind of give ourselves values for what we want. So if we have tan alpha is equal to 3, well, if we think about that, that means that that could just be 3 over 1, right? It could just be 3 divided by 1. So we can just say that this opposite side is 3 and the adjacent side is 1. We can write that, right? Because that's perfectly fine, right? Because that would still be tan alpha is equal to 3. And then for our hypotenuse, well, if we do Pythagoras theorem, that would just be a root 10 over here. So therefore, now that we've done that, well, what can we say? Well, we can say that when tan alpha is equal to 3, sine alpha is equal to opposite over hypotenuse. So that will just be sine alpha is equal to 3 over root 10. Okay? So now we've got that sine alpha is equal to 3 over root 10. And the same thing we can do for when we have tan alpha is equal to 1. Okay, we can do the exact same thing. So we'd have a 1 here, a 1 here, and that would just be a root 2 here. And therefore we can say that sine alpha is equal to a 1 over a root 2. Okay, so now I've looked at these two alpha values, or these two sine alpha values. We need to figure out which one will give us the greatest value, okay? So to do that, we effectively need to figure out which one will give us the greatest u value initially, effectively. And to do that, well, just by looking at these, it can maybe be a bit difficult. But what we can do is we can just put these values into our equation, into our u equation, okay? So if we do that, we get a u is equal to a 28 sine alpha. Let's do the 3 over root 10 first. So if you do 28 times by 3 over root 10, okay, let's do that on the calculators. So if we do that, 28 times a 3 over a root 10, we get a, I'll just leave it all as one go, we get a 42, root 10 over 5, which I'll write to a few decimal places. Let's say 26.56, okay? And then if we do it the other way, so we do a u is equal to, now we do a 28 and we're going to times by the 1 over root 2. It's fair to say this one will be smaller. Let's just double check. And then 1 over root 2, we get a 14 root 2. Don't know why I did that on my calculator. Did not need to, but it's done now. And that's a 19 point, let's say 8, right? So we know that, okay, for when it's 42 root 10 over 5, we know that's going to be bigger. So that's the value we're going to use. So we're going to use when sine alpha is equal to 3 over root 10. And now that we know that, well, now we can put that into our equation. So let me write down what we had initially. Okay, we had s is equal to, that's what we're trying to work out. Now we have u is equal to 28 sine alpha, but we've worked out that 28 sine alpha is actually the 42 root 10 over 5. Okay, that's what we've worked out now. So we know that's our u value. We know v will have to be a 0, and we have our a. Remember, we're dealing in the upwards direction, so a is a minus 9.8. Well, now we can use this SUVAT equation. V squared is equal to u squared plus 2as, which means that we have a 0 over here, u squared, so that'll be a 42 root 10 over 5. That's all squared. So this is keeping it exact. You could put 26, let's say 0.56 in. Let's keep it exact as possible. So 42 root 10 over 5 squared plus a 2 times a minus 9.8. That's a minus 19.6 s, okay? And then if we work this out, if you do a 42, so I'll do it as well. You do a 42 root 10 over 5 squared in your calculators. You will get exactly 705.6. That'll be minus a 19.6s. So therefore 19.6s is equal to a 705.6. Then if we just divide through, so 705.6 divided by 19.6, and we get exactly 36 meters. Okay, so for part D, the model does not include air resistance. State one other limitation of the model. So on these 1 markers, they come up a lot, and there's loads of things you can put. So for example, you can put like that it does not take, it doesn't take something like the shape, or sorry, my pen is being a bit annoying right now. Shape or dimensions, okay, of what is it, a ball we're dealing with? I think it's a ball, into consideration. Okay, you can say something like this. Okay, so it doesn't take the shape or dimension of the ball into consideration. So for question 6, we have a rod AB has mass m and length 2a. So again, when we have these type of questions, when we're dealing with rod, and when they specifically tell us that we have a length of that rod, right? Usually that means we're gonna have to take moments at some point. So okay, just bear that in mind. We know the rod is on rough horizontal ground, so at A there's gonna be friction somewhere. B has a smooth vertical wall, so there's no friction at B. We know the rod makes an alpha theta with the ground. It's at limiting equilibrium. So it's at the point of moving, but it's not moving. Okay, it's still in equilibrium, but it's at the point of moving. And we need to set direction of the frictional force acting on the rod at A. So let's just use this diagram we have here, and let's plot all of our values. Okay, so we know that A, there's going to be a normal reaction on the ground. Okay, so perpendicular to the ground. So let's call that R A newtons. Okay, we know that at B we're going to have another normal reaction to the wall, so it'll be perpendicular to the wall. Okay, so it'll be in this vertical shape. Let's call this RB newtons. Okay, we don't know anything about if it's uniform yet or not. So, but let's just say it's uniform. It doesn't actually make a difference for now. Let's just say that it's uniform. Okay, so it's uniform, then we're going to have a weight here of mg newtons, okay? And what they want us to do is they want us to figure out if the frictional force is acting to the left or to the right. So whenever we're going to have frictional force at A, the question is it going in this direction or is it in this direction, okay? Is it going to the left or to the right? Well, an easy way to think about it is if you look at what we've got right now, we've got 2 vertical forces, okay? We've got the reaction at A, that is the upwards force, and the weight, that is a downwards force, okay? So they are going to be perfectly balanced. We have this, now let's look at the horizontal forces, okay? We have the RB newtons, the reaction at B, that is going to the left, right? That's the leftwards force. But remember, we are in limiting equilibrium, okay? So everything has to be balanced. Well, what that means is in this case, the frictional force has to go to the right because it needs to balance the reaction at B. So for this question, you can literally say something like it goes to the right because it has to balance the force, has to balance, let's say the reaction, has to balance the reaction at B. Okay, something like that, perfectly fine, easy 1 mark. Now we're told that the magnitude of the normal reaction of the wall on the B is S. So I have RB, we just change it to S. And then we're told that it's uniform, okay, which is fine. And now we need to, by taking moments, show that S is equal to half mg cot theta. So on the page, I'm going to just draw a little diagram of this. Okay, so I've drawn the diagram now, and what else do we know? Well, we know the length is 2a in total from A to B. So we know that this length here, okay, we know this length has to just be half of that, so that'll just be A. We know that this length here then will also just be A. Okay, and the question says we take moments at A, we need to work out what this value for S is, okay? So, therefore, what we need to do first is we need to work out direction of the S, because we know that it has to be that perpendicular distance. So right now, if we look at S, okay, we've got two components for S. So we've got this component here and also along the slope as well. So we've got to figure out what this angle is here. Okay, so loads of ways you can do that. We know that this angle must be a sine theta, okay? Because if you think about that whole right angle triangle, that would be a sine theta, which would make this angle in between. This would be a theta. You can also look at that. Look at the theta we've been given. Those are like alternate angles as well. So you can look at it like that. And then this would have to be a sine theta here. So we know that it's going to be that S newtons is going to be at an angle of sine theta. We can also consider that down here is going to be a sine theta. And then if we just think about this, if I just do something like this, then we know that this has to be a theta as well. So remember, in that 90 degrees, okay, it's going to be an angle of sine theta plus the angle of theta, and those must add up to 90 degrees. So now that we've worked that out, okay, now that would be a, so result of the S, so that would be an S, okay, sine theta, okay, because remember, we has to be perpendicular, it's a perpendicular distance, so we need that S newtons to be perpendicular, so it'll be S sine theta, okay, and that is times by the length now, so that will be a 2a, and that is equal to an mg, okay, that is an angle of theta, so cosine theta, and that is just an angle of A. And now done that, we can cancel out our A's. So we're left with an S sine theta, actually it'll be a 2S sine theta is equal to a mg cosine theta. So then for an S is equal to an mg cosine theta over a 2 sine theta. And as you can see, cosine and sine theta, that would go to a cot theta. Therefore, S is equal to a half mg cot theta. Okay, part C, we are told that the coefficient of friction between the rod and the ground is mu. Given that tan theta is 3/4, we need to find the value of mu. That a tan theta is a 3/4. Then what can we do if we draw a little right angle triangle over here? This is a right angle triangle, supposedly. Okay, we get a 3 over here, 4 here, and a 5 here. So we know that a sine theta is equal to a 3/5. We know that a cos theta is equal to a 4/5. And to be honest, because we've got this cot theta, we're most likely going to have to use that cot theta and work that out. My pen is being very annoying. Sorry about this. A cot theta, that would just simply be a, well, if tan theta is 3/4, then a cot theta is a 4/3. So we know that to work out mu, okay, the equation is friction is equal to mu times R, where R would be that normal reaction at A. So if we work out our friction and we work out our R newtons, then we can just work out our mu. So how can we work those out? Well, in the previous question, we worked out what our S value is. We worked out that's half mg cot theta. So if I just work that value out, okay, we can do that. So we know that if S is equal to half mg cot theta, then that would just be a half mg times 4/3. Okay, and that would give me a 4 times a 6, so that would be a 2/3 mg. So we know S is 2/3 mg, so on my diagram here, I'm going to change this, and I'm going to put this to a 2/3 mg, okay. I've also got rid of the length lines as well, we don't need them anymore. And now we can just resolve by forces. So let's, first things first, let's resolve, that's a theta. Let's resolve the friction first. That's the easier one, I would say. So for the friction one, what would that be? Well, the friction would, if we resolve by forces, then that would just be A, F is equal to, well, just that 2 over 3 mg, okay? Because it's just horizontal. We know that S is 2 over 3 mg, so yep, it would just be a 2 over 3 mg. So now F is 2 over 3 mg. And for our R value, okay, if we resolve forces in the vertical, well, that would just be an R is equal to, well, we just have an mg there, so it would just be mg. Therefore, if we have F, we know F is equal to mu R. Okay, we know that F is equal to a mu R. Therefore, we know that that would be like a 2 mg over 3. Okay, that's the friction. That's equal to a mu of mg. Okay, and therefore that means that mu must equal a 2 mg over a 3. And then if we were to divide by mg, that's the same as saying times by a 1 over mg. Therefore, mg's just cancel out with each other, and we are left with 2 over 3 for mu. So for part D now, we need to work out in terms of m and g the magnitude of the resultant force at A. So what does that mean? What they effectively want us to do is right now we have, so we know what R newtons, we know R newtons is mg, we know that F newtons is 2 over 3 mg. We need to work out the magnitude of that. So if I do that on this page here, effectively all we need to do, this is part D, is if I draw two lines here, so we have these two lines here, okay? Let me make them straight, actually, make them straight. So we have these two lines right here. Okay, we know that with the R newtons, we worked that out. R newtons was just mg newtons, okay? And then with the F was 2 over 3 mg newtons, okay? So that was our F and our values. We need to work out the resultant force. So effectively, it's like if we had, like a triangle, and effectively it's like we're using Pythagoras theorem. Okay, we're effectively using Pythagoras theorem because we want to work out like pretty much effectively this length here, and we can work that out by using Pythagoras theorem. Okay, and that's all we need to do for this question. So therefore, it would be like an mg all squared. Okay, remember we want our final answer in terms of m and g. So we're mg all squared. Okay, and that would be a 2 mg. Okay, over 3, and that would be all squared, and then that would be all square rooted. Then if we work all this out, we get a m squared g squared. Then we get a 4m squared g squared over a 9. Okay, that's still all square rooted. This now we got, that's effectively the same. We can simplify this down, so that will be a 9 over 9 plus 4 over 9. That's a 13 over 9 m squared g squared. Okay, and then now we can get rid of that square root. So that will be a root 13 over a root 9, and that will just be an mg now. And then that root 9 cancels out, so we are left with a square root of 13 over a 3 mg. So last question, 1 marker, we have that there's a new model. The rod is modeled as being non-uniform, with its center of mass being closer to B than it is to A, okay? Now, a new value of S is calculated using the new model, with tan theta being equal to 3 over 4, okay? Same as before. State whether this new value for S is larger, smaller, or equal to the value of S in the initial model, okay? So effectively they're saying, if we go to, let me just do it on this diagram here, effectively, okay, what they want us to figure out is we're just looking at these two values here. So we know this is the S newtons. This is what we care about, okay? So if we look at the S newtons, and we're also going to look at the weight as well, the weight of mg newtons. What they're saying is this is the initial model, right? And in the initial model, it's uniform, so we have the weight right in the middle. And that is the initial model. But now what they're saying is now it's non-uniform, and now the center of mass is now closer to B than it is to A. So that would be like, let's say somewhere over here, right? Now we have mg newtons more closer to B than it is to A. What they're trying to say now is which value of S is bigger? Is it bigger in the previous value? So is it bigger when S was here? Or is it bigger when S is here? Okay, now think about it this way. If we were to take moments again at A, right? Then because mg, let's say mg was 1.5, right? We don't know what mg, but let's say the weight is now 1.5 A away from A, right? We don't know what it is. Let's just say it's 1.5 A. That means that for the clockwise moments, we would get like a 1.5 A value for its distance, right? And then that would also be like an mg, okay? We would have something like that. And as you can see, this is going to affect, because our clockwise moment is going to be bigger, this in turn means that our anti-clockwise moment will also be bigger because it has to match this new value now. So as you can see, if it's closer to B, it's going to have a bigger clockwise moment because the distance is greater. And if it has a bigger clockwise moment, it means that S will also have a bigger anti-clockwise moment. Therefore, the value of S is going to be bigger overall. It's going to be bigger. The closer the weight gets to the B, the bigger the value of S. So therefore, we can say that S will be greater because its center of mass is closer to B. That means that the clockwise moment of the weight will get bigger. So the value of S will also get bigger. Okay, and that is where we will end this paper. Pretty nice paper overall, I would say. But yeah, I hope you enjoyed this. In our next video, I'll be going over 2021, October 21 mechanics. So stay tuned for that, and I will see you soon.